This is a big picture review of Neurips, concluding remarks, and some outlook. Let me start with my impressions. What's my gut feeling? I think Neurips was an enormous experience for me. It was my first attendance, and let me just give a few sort of clues for people who've never been. It's a massive conference. The better you're prepared, the more you get out of it. You have to be prepared because there's a lot of things you can do. You can get lost, and you can definitely lose the forest from the trees. You have to have specific ideas. For example, I came there with two goals. One is better understand how transformer technology can impact robotics, or what is transformer technology in the first place, and how can it impact robotics. And then I wanted to particularly understand what advancements in reinforcement learning and embodied decision-making agents are being made. So those were my two main objectives. I've learned a lot of stuff that is not related to that. For example, the first paper, first paper that I discussed, flash attention, then the whole conversation whether RNN and CNN's convolution neural nets and recurrent neural nets, if they're actually, how are they related to the idea of transformers, which is a general idea that, for example, I came across Michael Bronstein's presentation here at Zurich, who was talking about graph neural nets and how they kind of relate to transformers. In a sense, if you think about this whole idea of transformers and graph neural nets, in essence, they're the same thing. You have certain, whether it's tokens or nodes, and they pass messages to each other. The only difference between a graph neural net and a transformer is the transformer passes messages from each node to every node, and that's self-attention, very compute intensive, versus graph neural nets don't have that. But in general, I think we are sort of in a world right now where a lot of terminology is being passed around. I think in the end, we're just going to call it learning, and whether it's learning through self-attention, through CNNs, RNNs, whether there is offline, or online reinforcement learning, but whether it's model-based or not model-based, those things will, I think, fade in the back. It's like, Buckminster Fuller said, the best airport is the one you don't even notice. The best technology, the best infrastructure, the best architecture is the one that you don't even notice. So, but of course, we're pretty far away from there. So that's why we have things like Neurips. That's why we go to these conferences. That's why we try to understand what's going on. A lot of work really on this front. So I started the conversation about more general theoretic stuff about LLMs. Also, I discussed, direct preference optimization, this new idea that you can sort of replace reinforcement learning with human feedback with, kind of offline reinforcement learning or maximum likelihood estimations. There's a very interesting paper that combines elbow with diffusion and sort of, if you think about it, diffusion is kind of a score matching function. Diffusion is really, you try to estimate gradients on the path towards a certain goal, versus elbow is more of I would say old fashioned maximum likelihood. You have a certain data set, and then you try to figure out which distribution does this data set belong to. So that was interesting. Data comp, one of the papers that discussed I would say, the fundamental paradigm of machine learning, which is data, architecture, model, algorithm. These things can be reversed. You can change your algorithm based on the data. The data influences your model. The model influences the data. All these things. I think really interesting paper out of UW. And then we had a section where we spoke about what DeepMind is doing, which I think is really exciting. Sort of prompt reader, self-debugger, and then fun search, chain of code. In general, what DeepMind is trying to do is sort of have almost a cascade of build agents that can call on functions that then help it solve problems, or call other functions that help solve sub-goals, which I thought was really interesting. There was a big discussion of tree of thoughts, chain of thought, I also discussed, Yannick Kirchner's PhD thesis, where I thought it was really interesting. It wasn't part of Neurips, of course, but it was sort of it was in part 5, where I discussed chain of thought, where I discussed why do we even think step by step? How do humans think? What does it, what's locality of memory? And Yannick's paper was interesting because it kind of, what does it say? Image classifiers might be biased during training and thus vulnerable to perturbations. When they learn what a dog is, they don't really understand what a dog is. They might be biased by low-dimensional data, which then can be perturbed, which is what he was discussing. We had some theoretical papers bridging reinforcement learning theory and practice with the effective horizon. When do transformers shine? The idea here is, in general, you can sort of separate an agent's ability to execute tasks into memory and credit. What that means is, okay, I know my world, I have a world model, but do I really understand which action leads me to my result? In part 7, I discussed video prediction models as rewards for reinforcement learning, which comes back in part 9. I think this is definitely a sort of a thread that goes through the recent discussions we had. So we have, think about it this way, we use videos to learn from videos. And what we don't want is just imitation learning. Okay, imitation learning is fine, but imitation learning doesn't help you out of distribution. So if you have to do something that wasn't learned in the imitation learning sample, well, then what are you going to do? So what you're trying to do is sort of embed experience or embed some sort of know-how that can be used and transferred to the new task. We have the problem of reward function design, which was also discussed in one of the papers that NVIDIA came, I think Eureka. Think about it like, okay, we can watch humans or we can watch robots. How can robots learn from other decision-making agents? Well, they have to find a way to design reward functions and then learn from those reward functions, learn new tasks. So that's, I think, really interesting. We had some discussions of multimodal foundation models, of course. Mavil came out of Berkeley under Sergey and some of his collaborators. And then the exploration exploitation concept, of course, was discussed. Exploitation, guided exploration for semantic embodied navigation. Knowing that there is a specialist gives you more confidence in tackling more specific problems. This opens the door towards the canonical definition of creativity, which is, can a robot define its own problems? That would be creativity. And then, does it have the intelligence to solve it? This was discussed in that paper. And I think the most interesting, in my opinion, the most interesting paper really is the last I discussed, where the authors use the diffusion model to, use YouTube data to train a diffusion model, and then use the diffusion model to generate video sequences, and then learn from those video sequences. So really, to summarize, I think Neurips 23, it was a foundation for foundation models for embodied decision-making agents. I think that door has been opened. I think the sort of convergence between convolutional neural nets, recurrent neural nets, graph neural nets, and self-attention, I think there's going to be a convergence. I think it's just a question of how many messages do you pass from which side to which. And then we have a whole slew of ideas of how to learn from observation, whether it's in video, whether it's real, whether it's imitation learning. We have some progress in how to some theoretical work, which I think is really important, in what exactly does what does a robot learn when it learns? I think Yannick's PhD thesis. Okay, what does it mean to understand what a dog is? And where is that? Where is in the latent space? Where is that knowledge? There's this one paper I mentioned that, where does reinforcement learning shine? Well, is it the memory? Is it the credit? How does the robot know which action actually gives it higher reward? Is it each action, or is it the combination of actions? Are we talking synergetics here? Those are very, very interesting open questions that I'm going to discuss in the coming months. Now, again, final words about Neurips 23. Be prepared. Go to any conference you can go. You're going to be around a lot of smart people that are not just smart, but that are thinking about the same problem as you are. The better you're prepared, theory is observation, laden. The better you know what you're looking for, the more you're going to find it. I think the robotics community is on the cusp of really changing the game with foundation models. There's a lot of work in latent space, engineering and understanding latent spaces and knowing why, let's say, disturbances can influence decisions, things along those lines. But I think fundamentally, foundation models, multimodal foundation models for embodied decision-making agents are a reality, and they're going to propel the field into the future. Thank you.